Good morning, everyone. I'm Soe Thandar, and I'm presenting today from the virtual conference room. Thank you all for joining this session. I'll be sharing my research on eco-friendly geopolymer mortar, a comparative study of alkaline solutions and vital ratios for enhanced durability. Let's start with the urgent problems we addressing. The cement industry contributes 90% of carbon dioxide emission in construction materials, posing a significant threat to our planet's sustainable future. And we are tackling two major waste management issues: sugarcane packaged powder from sugar production and fly ash from coal combustion, who currently create environmental hazards through landfilling and potential groundwater contamination. My innovative solution utilizes sugarcane packaged powder, which is the fibrous residue from sugar production. It is sustainable and rich in carbon, oxygen, and calcium. And the next one is my research combines fly ash, sugarcane packaged powder, sand, and alkaline solution to create the eco-friendly geopolymer mortar. And I'm focusing on setting time and 70 compressive strength as key performance indicators. My key objectives are to optimize mix proportion, to study sodium hydroxide molarities at first, to compare performance metrics, and to assess real-world feasibility. This is my expected application range from masonry construction to marine environments, including wall plastering, time adhesives, concrete repair, and high temperature application. And tested barrier combination based on the methodology, different fine ash to package powder ratios, various sodium hydroxide concentrations, multiple alkaline solution ratios, and all tests follow ASTM standards for consistency and reliability. This is my geopolymer synthesis process. And firstly, I combine with the sodium hydroxide solids and water to get the 5 molarity, 10 molarity, and 50 molarity sodium hydroxide solution. And also, and then combine with the sodium hydroxide solution and sodium silicate solution to perform the alkaline solution activators. When I get the alkaline solution activators, I mix with fly ash and sand into the mixer within 2 to 4 minutes. After mixing, I molded the specimen into the 50 millimeter mold based on the ASTM standard. After molding at 7-day curing ambient temperature, I got the fly ash based geopolymer mortars. The next one is for the fly ash and sugarcane package powder based geopolymer mortar. That process is similar way to the fly ash based geopolymer mortar. Firstly, I got the 5 molarity, 10 molarity, 50 molarity sodium hydroxide solution. When I combine the sodium hydroxide solution and sodium silicate solution, I got it, the alkaline solution activator. And when I mix with alkaline solution activators and fly ash and sugarcane package powder and sand into the mixer, and I mold it into the specimen into the 50 millimeter mold based on the ASTM standard. And I just mold it at the 7-day curing ambient temperature. And finally, I got the fly ash and sugarcane package powder based geopolymer mortars. This is the risk proportion for my research. So all of the tests are based on the basis property test and mechanical properties test. Let me detail my certain time findings. For 100% fly ash recharge and 90% fly ash and 10% sugarcane package powder, I found that 5 molarity sodium hydroxide show the longest setting times, approximately 250 minutes. So for 15 molarity sodium hydroxide, significantly reduced their approximately 150 minutes. So that higher sodium silicate ratio generally show their faster setting. So when I added the sugar package powder for the 90% 10% ratio, making the similar pattern to the pure fly ash. For the 70% fly ash and 30% SPB mixed with 50 molarity sodium hydroxide, show optimal setting time approximately 180 minutes. All composition show better workability than water. Now, for our official composition results, for pure fly ash, 100% fly ash and 0% SPB, the 50 molarity sodium hydroxide achieves 34.36 megapascal, and the higher sodium silicate content, the improved compressive strengths. So the 70% sodium silicate and 30% sodium hydroxide ratio show the best performance. With packaged powder addition, the 70% fly ash and 30% SPB mixture reach up to 43 megapascal with 50 molarity sodium hydroxide. Increasing sodium hydroxide molarities consistently improve the compressive strength. The 70% sodium silicate and 30% sodium hydroxide ratio consistently perform best across all mixtures. So the next one is for the density coloration. Pure fly ash mixtures show highest density, approximately 2.1 to 2.15 gram per cm3. The added package powder reduce the density slightly. 70% fly ash and 30% sugarcane package powder mixtures show optimum balance. So the density is 2.08 gram per cm2, maintain high strength while reducing weight, better workability than higher density mixtures. So we conclude, geopolymer mortars are a viable replacement for ordinary column cement mortar. So I found that the optimum mix was 70% fly ash and 30% package powder. And the best elevator was the 50 molarity sodium hydroxide with 70% sodium silicate and 30% sodium hydroxide ratio. And it can be achieved up to the 43 megapascal strength with improved workability. The setting time comparable to traditional cement and density strength balance optimal for construction application. Thank you for your attention. I'm now happy to take any question through the Zoom